Hey, this is Mike from Minimal 3DP, and today I'm continuing taking a look at the latest version of OrcaSlicer 2.4, which has officially been released, and we'll take a look at all the brand new features and some other cool stuff. So let's go ahead and get started. Now, if you take the time to look through the release notes, there's an alpha, beta, and then here just released, I guess, in the past 2 days is 2.4, and this is the official release now. But if you look through both the alpha, beta release notes, as well as the official release, there are just a heck of a lot of changes. One of the big ones is the Orca Cloud, and we'll take a look at that probably in our next video. But today I want to look at more of the structural changes that are going on. And these include bridging as well as the changes to some of the infill. Now, I found this definition of bridging over on Creality's website. And as you can see here, what it basically is, it's a term used when you're laying down filament between 2 points with nothing underneath the filament you're laying down as support. So basically you're printing midair. If the filament doesn't cool fast enough, it tends to sag. Now, I found this image where you could see this really well. And you can see, again, filament between 2 points, and the initial filament that's in the air, the one down towards the bottom here, that's sagged down. Now, over time, as you got more layers laid down, it sort of straightened out. But you still have this saggy area, and you'll have this one where you're bridging between 2 points. But you can also see this where you have severe underhangs, you have overhangs, and you don't have support holding it up. In some cases, once support adds time. I found I do a lot of print and place animals, and some of those, and let me load something up so I can show you. So here's an example of a print I had a problem with recently. I think I mentioned in one of my last videos, I was printing a bunch of little animals to give to kids for a giveaway at a local park. You can see from this model, it's low poly, and it turned out with this overhang here, you wound up with stringing underneath here, and it didn't look great. Now, with that being said, this is a raccoon, and it looked like, as a trash panda, it looked like it was holding trash in its paws, so I didn't worry too much about a little bit of spaghetti down here underneath. But these are the kinds of areas where bridging can be an issue. In my case, let me switch back over. I have a little bridging test I found online that's pretty quick to print. I'll add the link to this model in the video description so you can see it. Now I have what I considered my optimized settings here for printing with my K2 Plus. Now, with the latest settings, let's take a look at where those fall into place here and what different settings are available. So the first change I've noticed is over here under line width. You now have a bridge line width. It was, I believe, the old setting was automatically pulling from the line width for the internal solid infill, which mine is set to 125, which I believe with a 0.4 nozzle is about 0.46. The recommended setting is just leaving the bridge width to be equal to the nozzle. That way you have more lines and you can play with the density. The way you can see more information is just click on the word bridge, and this will bring you over to the wiki. And you can see here is the recommended value. And then you'll also see bridge density. I'm going to click on that, and we want to do, the default is 100%. So we want a density, according to this, higher than 100%. So let's find the setting here, and we'll change that. Now, I'm going to be honest, I'm not exactly sure where this new setting is. So if I just hit the search here, I'm going to search for density, and we'll look through the list here, and here's internal bridge density, external bridge density. So let's click on that. Well, it turns out these are down here at the bottom, and I'm going to up these to 110%. Now, let's check the settings and see if there's any recommendation. Now, according to the wiki here for thick bridges, this can cause some problems, but there is a recommendation here of doing this for internal bridges only. Going back over to my settings, that's already set. We're just going to leave the thick external bridges as off. Looking down here, extra bridge layers. If I read this correctly, it's looking like we need it at least on the external bridge only. And so let's go ahead and change that. So extra bridge layers, let's change it to external bridge only. So that'll help us out. And let's continue looking down this list. Now I'm trying to see if there's a recommendation for these filters. I'm not seeing anything, and we're just going to leave those as off. Now in the release notes, some of the other changes, let me find these, is there's a relative bridge direction, align bridge with the model. So that's align infill direction model. And I think we can go ahead and turn that on. So I'm going to search for align infill. Now to find this setting, again, I use the search and it's under advanced align infill direction model. I'm going to check that. Now we also have bridge infill direction, so we can mess with that as well and nudge that. Now the relative bridge angle, let's take a look at what that setting is. We want to add a small angle, less than maybe 10 degrees, to improve bridge covering in closed shapes. So here is 0. You'll notice again, here's a 2%, 8%. And let's go ahead and we're going to set that. I think I'm just going to set it to 5%. So we'll see what that does to our model. And relative bridge angle. So I don't actually set this. All I do is check it. So we'll go ahead and do that. And we'll take a look at what this does to this model. So I'm going to slice it and then we'll send this to the printer. Now this next change in optimization has to do with infill. And this is basically a different way of doing gyroid infill. And I think it's sort of neat because if we look at the release notes, it was developed at Brown University as part of a NASA grant in collaboration with Elegoo and Polymakers. That's pretty cool. And basically, this is a new way of looking at how it's optimizing the gyroid wave. And from reading this, it looks like this architecture had a increase of 60% compression strength and strength to mass. So we're going to see if we can tell a difference here. So let's switch over and take a look. So in the case of the gyroid, there's only one setting here we need to change. And this has to do with the resistance under buckling compression. So I've done two models, one with normal gyroid, one with gyroid, and then I've gone ahead and checked the Z buckling bias optimization. And so I'm going to print those and we'll take a look at those and see if we can really tell a difference here. That's going to take 15 minutes to print both those little models. I'll print those and we'll take a look. So I printed out my two models for the bridging test. This is the model with my existing settings. Now I'm looking at the quality, at least the surfaces. The top here looks a little wavy on both of them. Now, I think that more is a function of they're fairly warm when I pulled them out of the printer. Now I'm noticing on the one with my existing settings, you can see some stringing in there. And I actually think when I hold this up to the white, I can see through this a little bit better than I could on the one with the new settings. Now, there's no stringing there, so that's good. And the underneath, particularly this one, looks really good. This one still has some string underneath, or at least some sagging. And same as this. I'd say the quality is better, but I'm not going to say it's light years better or that big a difference. Now, I think in my case, I'm going to leave the new setting set. Sorry, I just kicked the desk, so I apologize. So I'm going to leave the new settings on because I do think that improves quality a little bit. Give it a couple minutes, I'll print out the gyroids and we'll take a look. Now here are my two gyroid examples. So this is the old gyroid. And you can see it's significantly different than the new gyroid. And Now what I'm seeing is the wavy line's going to cross here, but now I'm also seeing thicker lines going in the Y direction. I can't tell if either one's using more filament or not. Time-wise, they appear this adds a little bit of extra time. Gyroid itself is slower than cubic. I'll have to run some tests and decide what I want to do here, but I may actually leave it on this new setting. And this does feel pretty solid. And I mean, I only did one wall, I believe, around the edges, or two walls around the edges. So I'm pretty pleased with this. And I think this a new fix, it also looks like, I mean, I'm really liking the way this new gyroid is looking. Again, if this gives us a mass compression ratio that's significantly better, it's probably something I need to be using. Now, I need to do a little research to figure out the types of parts this would work best with. But again, this is another great new feature that OrcaSlicer has added. So I hope you found this helpful. If you have any questions or comments or see a feature I need to highlight, please let me know. I look forward to talking to you again soon. Thanks. Have a good day.